Hello everyone. In this session we will discuss about second lab program from machine learning lab. The second lab program is to implement candidate elimination algorithm. The aim of this algorithm, for a given set of training data examples stored in a CSV file, implement and demonstrate the candidate elimination algorithm to output a description of the set of all hypotheses consistent with the training example. The learning objectives from this lab programs are here you will be making use of data sets in implementing the machine learning algorithm, that is candidate elimination algorithm, and you will be implementing the concepts and algorithms in Python language. The key idea in the candidate elimination algorithm is to output a description of the set of all hypotheses consistent with the training examples. This subset of all hypotheses is called the version space with respect to the hypothesis space H and the training examples D, because it contains all possible versions of the target concept. So here the set of hypotheses in the version space, it is consistent with the training example, and it will make sure that those hypotheses will the concept learning for the target concept. The candidate elimination algorithm represents the version space by storing only its most general members G and its most specific members S. So here the version space here in this candidate elimination algorithm, it will make the specific hypothesis more towards the generic form and the general hypothesis to more towards the specific form. Okay, so in between the set of hypotheses which will involves which consists of the training example which are consistent with the means the all the possible versions of the target concept. So that is a candidate elimination algorithm. So here in the candidate elimination algorithm, the examples are added one by one. Each example possibly strings the version space by removing the hypotheses that are inconsistent with the example. So that's why the name candidate elimination algorithm. So here, which are the hypotheses which are inconsistent with the training example, those hypotheses will be removed from the set of hypotheses. So the candidate elimination algorithm does this by updating the general and the specific boundary for each new examples or each new training example. So here whichever the hypotheses which are inconsistent, so those hypotheses will be removed. So here you can consider this as an extended form of find-S algorithm. And candidate elimination algorithm, it considers both positive and negative example. Actually, positive examples are used here as find-S algorithm. Basically, there are generalizing from the specifications, while the negative example is specified from generalized form. So here we consider both the examples, positive and negative example, but in find-S algorithm we were considering only positive example. So that is the one main difference between find-S and candidate elimination algorithm. So this is the algorithm for candidate elimination algorithm. So here we need to initialize general hypothesis, maximally general hypothesis, and maximally specific hypothesis, yes. Then we need to for each training example D, if D is a positive example, then we have to do the same like how we solved in find-S algorithm, that we need to compare attribute value with the hypothesis value. If both are same, no need to change anything. If the attribute value is different from specific hypothesis value, then we have to replace it with a question mark. If D is a negative example, then we need to check the inconsistent data in that, and those inconsistent hypothesis we should remove from the general hypothesis. So that is all about this candidate elimination algorithm. So to easy to understand, so step one, we are in the implementation of candidate elimination algorithm. So step one will be loading the data set, and here we'll be using .csv file to store the data set. Then step 2 will initialize general hypothesis and specific hypothesis. Step 3, for each training example, if example is positive example, then we have to compare attribute value with the hypothesis value. If both are same, then do nothing, we keep the same value. Else we need to replace the attribute value with the question mark. Means here we are making the specific hypothesis into a more generalized form. Then in step 5, if example is negative example, then make generalized hypothesis more specific hypothesis. So that is a candidate elimination algorithm. So we'll take one example and we'll see how to solve this problem by using a candidate elimination algorithm. So this is the data set we are taking. So here we have 7 columns. So in this the 7th one, this is the target concept. So here we have 3 positive example and 1 negative example. So initially we need to initialize this general hypothesis and specific hypothesis. So initially we'll initialize the general hypothesis with all question marks. So here we have 6 attributes, that is sky, air temperature, humidity, wind, water and forecast. So we'll make all the 6 attribute values as question mark, and in specific hypothesis we'll make it as a null value. So in the first iteration, so this is the first training example x1, and g1 will we keep as it is. Then s1 will be the whatever the value we have, attribute value we have in x1, that will be copied into specific hypothesis because it is a positive example. Then in the iteration 2, we will take the second training example, and g2 will be same, and s2 in the iteration 2 we will compare x2 with the s1, specific hypothesis 1. We will compare each attribute value. So here sunny, here also sunny, warm, warm, but in the third attribute normal. So s1 is having normal and x2 is having high value. So there is a difference in the value, attribute value. So we will make the change as a change in the s2 as question mark. Okay, so next strong is same, warm and same. So all the values are same. So this will be the specific hypothesis after iteration 2. Then in the iteration 3 we have a negative example. So here if it is a negative example, we need to, negative example means those are inconsistent data. So what we have to do is we need to make those negative example move towards the positive example or specific hypothesis. So here x3 will be comparing with s2. So here in s2 we have sunny, s3, so sunny. So here it is rainy. So s3 we will make the changes as in g3 we will make the change as sunny, and all other attribute value as question mark. Okay, so then in the next one, here the second value is cold and s2 it is warm. So there is a change in the value. So what we have to do is we have to write warm here because s2 is having value warm. So all other attribute value we have to make it as a question mark. Then in the third value it is in s2 it is a question mark. So here it is high. So already it is in a general form. So no need to do anything for this attribute value. We'll just leave it. Then strong and strong, it is both same. So no need to consider this also. Then warm. So here it is same, so we'll ignore this. Then same and change, so there is a change in this value. So what we have to do is we'll just write the S2 value, attribute value, that is same, and all other we'll write it as a question mark. So this becomes the G3 general hypothesis, and this becomes the S3 from the iteration 3. Now fourth iteration, we'll consider fourth example, a training example, and S3 becomes, we'll compare this S3 and X4. So here it is sunny, here also sunny, warm, warm, here it is question mark, and here high. So we'll keep the question mark because it is in a general form. Then strong, strong, warm, and here these two values are different, so we'll make that as a question mark. So this becomes S4. But here in the specific hypothesis, we have done the change in the sixth attribute, because here it is same and here it is changed, so we have made it as a question mark and in more generalized form. But in G3, we have done that as a same, so we have done the general hypothesis as a more specific form. So what we have to do is we have to make this also generic form, because S3 in S4, that the sixth attribute value is modified as a question mark. So what we will do, we will remove this. We will be going to remove this inconsistent hypothesis from the general hypothesis. So finally the G4 becomes sunny, and with the attribute value sunny and warm. So this becomes the most general hypothesis from this algorithm. So this is the most specific hypothesis, and this becomes the most generic hypothesis. Okay, so this is nothing but the version space, so set of hypotheses which are consistent with the training example. So same thing we'll implement with this Python language. So here the first line is import CSV. So we are importing the data set from the CSV file, and we'll create one list to store the training example. Then we will open the CSV file in a read mode as a CSV file. Then we'll copy that CSV file into a variable. Then from this variable we'll append this training example one by one, means row by row. We will add it into a list A. So then we'll just print to see the values. Then next we will be calculating number of attributes in this training example. So here we'll take the length of a list. So how we will take? So we'll take a one row from the list A. Then we'll count the number of columns or number of attribute value. So here we will get 7, because it is including target concept. So 7 minus 1, we will be getting the real attribute numbers from this training example, that is 6. So number of attribute variable will be having the value 6. Next we will be initializing specific hypothesis and general hypothesis. In specific hypothesis we'll just print it as with all values 0, the 6 attribute values as 0, and in general hypothesis we'll print it as all values as a question mark. So then we'll just print this S and G. So this will be the value in S and G. So then we'll create one list called temp to store generic hypothesis from each iterations. Then we'll just take the first positive example, and we'll just copy the values from the first training example, positive training example, into the specific hypothesis. Yes, so here the specific hypothesis becomes this, that is with the value sunny, warm, normal, strong, warm, and same, and general hypothesis remains same with this in this format. So now we'll go to the next line. So here what we have to do, we have to consider the first training example. Then we have to check each values with the specific hypothesis. If there is any difference in the value, we have to replace with the question mark. So here the first training example and the specific hypothesis yes value is it's all the values are same. So what happens, we are not going to change anything, so S1 remains the same. So here if a of I and number of attributes, that is nothing but a of 0 to 6. So I value will be taking it as a 0 because that is the first training example. So this is the first training example with the value sunny, warm, normal, strong, warm and same. Okay, so then we will take the first attribute value sunny, that we will compare with the specific hypothesis yes. So this is not equal, actually these are equal, but here in the condition we have written if s of j is not equal to a of ij, then you change the s of j as question mark, so it is false here. So all the attribute you will get answer as false. So we are not going to change any value, we will keep as it is. So here so now this is done. Here it will not go to this part because the temp is not at values not yet created. So now it will go to this if condition. So here the target concept is no. If the target concept is no, then only it will execute all these codes. So it will come out of that. This condition is false, so it will come out of this and it will just print the yes value. So S value will be same. If the length of temp is equal to 0, then print G. So here temp is not having any generic hypothesis from this training example. So it will print the initial general hypothesis G. So this is the first iteration. So next we will go to the second iteration with the second training example. So this is the second training example. So we need to compare this with the first specific hypothesis from the first training example. So now here in the third value there is a difference. So here in the first training example the third value is normal, but here the third value is high. So there is a change in this particular condition where normal is not equal to high. So that is true. So if it is true, what happens? S of j becomes question mark. So that we will do the changes in this specific hypothesis, and all other attribute values are same. So we are not going to make any changes in this. So here all these condition it becomes false and it will print the yes value. So it will print the S value and length of temp is also 0. So it will print the G value as same. So now the third iteration. So this is a third training example. Actually this is a negative example because target concept value is no. So here in the third iteration, this is the specific hypothesis we are considering here for the third iteration. So here in this particular code, so here if it is equal to yes, so it is false, right? So it will not go, it is not a positive example. So it will come down here. So if a of I is a of I of number of attribute is equal to no, yes. So it will come to this. Okay, this condition becomes true. This condition becomes true. So then now we have to execute this part of the code. So what here we are doing? So if a of ij is not equal to s of j and s of j is not equal to question mark, then we have to keep the general hypothesis equal to specific hypothesis. Okay, then we have to append that into a temp list. Then we need to display the G value. So this is what we are going to do here. So now J is equal to 0 means we have to compare. So here we will be comparing this with this specific hypothesis with this training example. So here a of 2 of 0, 2 means this is the third training example. So 2 of 0, so that is rainy. So rainy is not equal to sunny. So this is specific hypothesis. Rainy is not equal to sunny, and specific hypothesis 0. specific hypothesis 0 is not equal to question mark, and here it is not a question mark, means it is not a general form. So both are true, right? Both are true, so the condition is true. So what happens, we need to, if it is true, if both the conditions are true, then we need to change g of 0 as sunny, and that will append into temp list. Temp is nothing but a list, and we remaining that we will write it as a question mark. So remaining number of attribute will make it as a question mark, so that becomes the temp value. Okay, so that becomes the temp value. So next what happens, next again j value is 1, again we will be comparing the j value a of 2 of n, 2 of 1, so that cold is not equal to warm, the second attribute value. Cold is not equal to warm, and s of 1 is not a question mark. Here we have a value warm, so it is not a question mark. So what we, if both the condition is true, so what we have to do, g of 1 we have to make it as a warm. So here the first and the last all four becomes question mark, and second one we'll make it as a warm. So that will append into the list temp. So next j is equal to 2, again we will compare. So here high is not equal to question mark, so here it is high and here it is question mark, so it is already in a general form, generic form, so no need to do anything here. Next fourth one strong, here is strong, so no need to do anything. Next warm, here also warm, no need to do anything. And the last one, here it is change and here it is same, so we need to make it specific. So s value here we will make it as a here we will make it as same. So here we will make it as same. So here the j is equal to 5. So all other attribute value we make it as question mark, and the last one will make it as same. So and this will become the temp, the list temp. So after this we are going to print this. So once it is done, it will come out of this condition, then it will print s value. So s value will be this, and length of temp is equal to 0. So here the temp is not equal to 0. Temp length is not equal to 0. So it will come to the else part and it will print the temp value. If the temp value is empty, means temp is not having any element, means it will print the initial hypothesis, general hypothesis. But here the temp is having some element, right? So here it is having 3 elements. So it will come to the else part and it will print the temporary list. So this is a third iteration. Now we will go to the fourth iteration. So here we are considering the fourth training example. So it is also a positive example. So directly it will go to this condition. So again it is going to compare. So here what happens? So first attribute value is sunny, second is warm, and third it is high, and here it is a question mark. So if there is a change in this value, so we have to make it as a question mark. So it is true, so we'll make that as a question mark. Again in the fifth and sixth attribute also there is a change. So here it is warm, here it is cool, here it is change, and here it is same. So that also we'll make it as a question mark here. Okay, so s of 4 and s of 5 both becomes question mark. So now, so here it will not go to this condition because it is a positive example. So it will come here and it will print the s value, that is sunny, warm, question mark, strong, question mark, and here temp is not equal to 0. Okay, it is not equal to 0, it is false. So it will come out of this and it will go to the else part and it will print the temp value with the 3 elements. Okay, so this, the after fourth iteration we will get the value like this. But here what happens, in the S3 the last value, that is same value, same attribute value is changed to generic general form. Okay, generic value. So now according to this we need to change the this general hypothesis. So for that, this particular part of the code will be executed. So here we need to compare the temp value with the specific hypothesis. If temp of kj, if it is not equal to s of j, and temp of kj is not equal to question mark, then we need to delete that hypothesis. That means it is not consistent. That particular value, it is not consistent with the specific hypothesis. If that kind of hypothesis is there in the temporary list, then we need to delete that, or we need to eliminate that hypothesis from the temp. So that is the concept here. So what we will do, we'll now again what we have to compare. So this is the S3 value, that is a specific hypothesis. Then this is the temp value. So now temp is having 3 elements. Okay, three element, nothing but the 3 hypothesis. Now one by one we'll compare. So j is equal to 0. Okay, so j is equal to 0 here. J is equal to 0 means the element attribute value, but here the temp value k is nothing but which will track the elements in the list. So k is equal to 0 means it will point to this particular value. So here we will compare temp of 0 to 0 is not equal to S0. So S0 means the first value, that is sunny. So here in temp also it is sunny is there. So here also it is sunny. So sunny is not equal to sunny. That is false. Then sunny is not equal to question mark. So sunny is not equal to question mark in S3. Right. So temp of 0. So here sunny is not equal to sunny, and sunny is not equal to question mark. That is true. So false and true, it becomes false. Okay, so if it is false, no, do nothing. So next go to k1. So if k of j, again we compare this, that is in k of 1. So here in the first second element, so here that is a question mark. So here the first attribute value is question mark. Okay, so first attribute j value is nothing but first attribute. So here it is a question mark. A question mark is not equal to sunny. So in S3 the first value is sunny. So it is not equal to sunny. That is true. And temp of 1 of 0 is not equal to question mark. Okay, so that is false. That is false. So here it is warm, right? The temp of 1 of 0. So that is nothing but warm. So it is false. So do nothing. Again like this we need to go to the all the attributes. Now you go to the fifth attribute from the specific hypothesis, and in the temp list we go to the again we need to go to the second value. So here one by one we need to check. So now k is equal to 0. Again we need to check here. So the first attribute value is question mark here, and here also in the specific hypothesis also it is question mark. So false. So everything you will get it as a false. And the last attribute value, so here it is same, but here it is question mark in the specific hypothesis. So temp of 2 to 5 it is a question mark, and there it is a same. So same is not equal to question mark, and same is not equal to question mark. So what happens? Both are true. So answer is true. So if it is true, then what we have to do? We have to delete the temp of k. K is nothing but 2. So this is k value. So k is equal to 2. So we need to delete this hypothesis from the temporary list. So what happens once we remove that? So now we need to print the specific hypothesis, and here it will check if length of temp is equal to 0. No, here the length of temp is 2, right? So it is a false. So it will come out of this if condition, and it will go to the else part. So here else part it will print the temporary list. So that is nothing but sunny with the attribute value sunny and warm. So this becomes the maximally general hypothesis G, and this becomes maximally specific hypothesis S. So that is the output from the from this lab program. So this is the output, how you this is the output for this program. So these are nothing but the training example, and this is nothing but the initial values, and these are the each training examples specific hypothesis and general hypothesis. So this is a CSV5 for what we are considering for this particular program. So now we will go to the Jupyter notebook and we will execute this program. So this is a Jupyter notebook. So you have to go to your command prompt here and you have to type Jupyter notebook. So just enter this, you will get the Jupyter notebook interface in your default browser. So this is a Jupyter notebook Jupyter notebook. So here I have opened the second lab program. This is the program what I explained now. Okay. So this is the second lab program. So now I will just save and run this program. So this is the output what you will get. So this is nothing but the training examples what we have considered. So 3 positive and 1 negative example. This is the initial specific hypothesis and this is the initial general hypothesis. This is the first training example, positive training example, for the first training example what we got the specific hypothesis, and this is the general hypothesis for the first iteration, first training example. This is for the second training example. When we compared with the first hypothesis, we got this updated specific hypothesis, and this is the general hypothesis for the second training example. The third one, it is a negative training example. So there is a change in the general hypothesis. So we have 3 hypotheses here in the general hypothesis. Okay, so in the fourth iteration, this is for the fourth training example. So there is a change in the specific hypothesis in this particular value, the same value. So that's why we are going to remove this particular hypothesis which are inconsistent. Okay, which are inconsistent with the training example. So we are going to remove this from the general hypothesis. So finally this is going to become the maximally general hypothesis, and this is the maximally specific hypothesis. So this is the output for this lab program. So that is all about lab program 2, where you are going to implement a candidate elimination algorithm. So hope you have understood the concept of candidate elimination algorithm. If you have any doubt, you can get back to me. Thank you.